Good afternoon, y'all. Today we're going to do net ionic equations and acids and bases. This is the third video of 4 for chapter 8. Hope y'all are doing great today. So remember last time we talked about precipitation reactions. So now we're going to take that knowledge and we're going to add to it. So there's going to be things called a molecular equation. That's what we've been doing before. That's just a normal equation with the states of matter that's balanced. Complete ionic equations, if you look down here at the bottom, it's where everything is broken. And we only break ones that have AQ, and we break them into their ions. So notice here, magnesium hydroxide, which is solid, does not break. Only AQ breaks. Okay. So aqueous break into their ions. Everything else stays in its normal molecular form, the solid, the liquid, or the gas. Okay, so once you've broken them, the ions, there's some of them that are the same on both sides. And those specifically are called spectator ions, and that's because all they're doing is watching. They have to be exactly the same on both sides, including their coefficients. Okay, so we've got 2 nitrates on the reactant side and 2 nitrates on the product side, so they cancel out. They're just watching. Same thing with the potassiums. They're just watching. Okay, and then the net ionic equation is whatever is left. Okay, you've removed the spectators. All you have is your solid product or your liquid or your gas, and then the whatever's left of your aqueous reactants. Okay, so here we've got another example. We've got our molecular formula, again, just the normal formula. We break them into ions. So this 2 came from that subscript. Sulfate doesn't have that. That 4 belongs to the O. Okay, and that charge is 2 minus. You do have to make sure your charges are right. This coefficient went to silver and nitrate because it was a coefficient. So notice silver has 2, but so does nitrate. Okay, it's going to be the same with potassium nitrate as the products, 2 and 2, and then silver sulfate stays together. Remember, the spectators are the ones that you cross out. So in this case, if I asked you the spectator ions, they would be potassium and nitrate. And then the net ionic is you write whatever's left. All right, let's look at one that's a little more complicated. So this one has 3 products. Notice it's got a gas and a liquid. Those will still stay together. Only aqueous break. Okay, so we still cross out our spectator ions to get our our net ionic. Then what I have left is carbonate and 2 hydrogen ions yield carbon dioxide and liquid water. All right, so we're going to do the whole thing except starting, they gave us the molecular equation, which is nice. So this is complete ionic is first. Okay, I've got 3 SR, and then SR's charge is 2 plus. Make sure you have a not a calculator. You will need that in a minute for this video. But make sure you have a periodic table so you know your charges. I've got 6 Cl minus, and that's because this coefficient multiplies by that subscript. I also have 6 lithiums, because again, same thing. I do only have 2 phosphates because that 4 belongs to phosphate. Okay, my strontium phosphate stays together, so Sr3PO4 2 is still a solid. Then I've got 6 lithium ions and 6 chloride ions. Okay, complete ionic. Net ionic is whatever is left. So I have 3 Sr2 plus. I'm getting rid of chlorine and lithium. Those are our spectators. We'll write them in a minute. And I've got 2 phosphates to make our strontium phosphate solid or precipitate. Remember, that's what it's called in these types of reactions. So then I'm going to write our spectators just so we see them. Li plus, Cl minus. Okay, if y'all have any questions, please let me know. We're going to do a couple more. Okay, again, they gave us the molecular. So I've got 2H plus 2I minus. I'm going to leave out the AQ, but no, on Mastering Chemistry, you are going to need to go ahead and put those AQs in there. 1 Ba2 plus and 2 OH minus yields water stays together because it's a liquid here. Water cannot be aqueous, y'all. Please do not put that. All right, so that's our complete ionic. Our net ionic is 2H plus 2OH minus yields 2 waters, so that's our liquid. You could also write just H plus because everything has 2 in front of it. And that's only because all of the coefficients are the same, so normally we would reduce them. Then our spectator ions are barium and iodine. Okay, we got one more. So on this one, I'm just going to write the net ionic because sometimes they just ask us to do the net ionic. So I'm going to show you the easier way to do this, but this only works if they don't ask for the complete ionic. Okay, so look, I know I need, this is my product for the net ionic because it can't break. Okay, so magnesium breaks and nitrate breaks. So it looks to me like I have 2 silver ions and 2 chloride ions. Okay, but this only works if you just need the net ionic. If they need the complete ionic, you've got to put them all out there. Like, you got to write it all out. Okay, so now we're going to switch over to acids, and then we're going to go back to net ionics, but with acids. So acids are molecular compounds that form an H plus ion when they dissolve. So if we look at this equation they gave us, we've got hydrochloric acid, and we'll talk about how to name them in a minute. This gave up a hydrogen to water, because if you look over here, we've got this H3O plus. So that is my acid. Okay, acids are usually have that hydrogen at the beginning. It is important to note that most of the time the hydrogen is not at the end. Acids do have a sour taste. Most of what we eat is acidic, and then they will dissolve specific metals, or most metals actually. So an Arrhenius acid is one that produces H in solution. And then there are polyprotic acids. That just means they have more than one H plus, and they'll lose them sequentially. And that'll make more sense when you get to Chem 2. And if there are 2 of them, so here's a polyprotic acid, because it has more than one hydrogen, because of that 2. This one specifically is called diprotic, because there's 2 hydrogens that are come off. But it is important to note that the first one is going to be strong. Okay, the second one will be a weak removal of the acid. And then an Arrhenius base is a substance that produces hydroxide in solution. So anything that has OH is normally going to be a Arrhenius base. So here's a list of some common acids and bases. So for naming acids, there are 2 types of acids. There are binary ones. They have a H and a nonmetal anion. Okay, and then there's oxyacids. They have an H and then a polyatomic anion, and it's going to have oxygen included in it, which is why it's called an oxyacid. So for binary ones, this is just 2 elements only, a metal and a nonmetal. Sorry, not a metal. A hydrogen and a nonmetal. So you always start with hydro, and then the root of the nonmetal, and then you put ic acid. So here they have HI, hydriodic acid. Okay, then for oxyacids, you will need your polyatomic chart for this. And what's important to know is that 8 goes to ic acid, and ite goes to OUS acid. Okay, and some students like to remember it like this. Sprite is delicious. Okay, so Sprite is delicious. The ite goes to OUS. Everything else is an ic acid. What is important to note also is there is no hydro when oxygen is present. Okay, there are some polyatomics that have hypo, but hydro and hypo are different things. Okay, so the first thing you want to do is determine what kind of acid it is. So here I'm going to just determine this is binary, oxy, oxy. Okay, so binary always has hydro. That was awful. Hydro, and then S is sulfur. So sulfur is weird. It doesn't take anything off when you're naming it an acid. So it is hydrosulfuric acid. Okay. This was oxy acid we sent. So this, you need to look at the back part, the anion. That is chlorate. Remember, 8 goes to ic. So this is chloric acid. This polyatomic is acetate. And remember, 8 goes to ic. So this is acetic acid. Okay, now we're talking about acid-base reactions, which are commonly called neutralization reactions. And this is when an acid and a base react and they will neutralize each other to make water. And it's important because water is a neutral compound on the pH scale. Okay. Also, there will be whatever is left is going to be called a salt. So here we've got acid, base, this is salt, and then this is water. Also note this water is liquid. Everything else here is going to be aqueous, which means this will always be the net ionic for an acid-base reaction. So if you see an acid-base reaction and it asks for the net ionic, it's just always going to be that same thing. H plus OH minus yields water. It is important to note that neutralization reaction doesn't always mean it'll have a pH of 7, and that'll become more apparent in chapter 16. Okay. However, in a neutralization reaction, the moles of acid should equal the moles of base, which is going to be important in a few minutes. So remember we saw that H3O plus earlier. That just is a hydrogen added to water. So you're going to see those a lot. It's just going to be H plus or H3O plus. They're interchangeably used. Remember, bases are going to dissociate or break apart into OH minus ions. So this neutralization reaction will take this H and this OH, and they're going to make water. And then whatever's left, you put together the correct way. And it's called a salt. Any salt is going to be an ionic compound. This one does happen to be table salt, but they're not all table salt. Okay, y'all? So this one is, obviously. Okay, so we're going to do a neutralization reaction. I've got HI, says it's aqueous. That's hydriodic acid plus barium hydroxide, aqueous. Okay, remember, they always make water. So I generally always put water as the first product. You don't have to, but that's what I do. Okay, then we need to come over here. I have not used barium. I have not used iodide. So that's what's left. Ba, and then I2. That 2 comes because barium has a 2 charge. Remember, halogens are soluble unless there was silver, lead, or mercury, which is not that. Okay, so now we need to go back and balance it. So as for balancing goes, I need a 2 here and a 2 there. Okay, this one just asks for the net ionic, not the complete ionic. Remember, all net ionic for acid-base reactions are going to be hydrogen plus hydroxide yields water. All of them. This is the easy one. So if that one appears on the test, Pay attention. That's the easier one of them. Okay, one more. HBr and Li. Lithium hydroxide. Makes water. And whatever's left is lithium bromide, aqueous. Okay, that one is balanced, so we're good to go. Okay, so now we're having to write the whole thing. We're writing the molecular, the complete, and the net ionic for an acid-base reaction. Okay, remember, water is always liquid. Plus whatever's left, I have a K, and I have an acetate. Remember, all acetates are aqueous. So this is our molecular. It is balanced. Our complete is H plus C2H3O2 minus plus K plus OH minus yields water plus K plus acetate. And then our net is H plus OH minus yields H2O liquid. Okay, there's one more. If you'd like to do that one, you're more than welcome to. Okay, so let's predict some products. Remember, water is always going to be what's left in liquid form. And then I've got barium and chlorine. And it's not balanced, but it doesn't say to. So I've got water. Whatever's left is lithium and sulfate. That's it for the day. I hope you all have a great day, and we'll do the last one next time.